mass percent. Okay, so the mass percent is defined as the mass of your solute divided by the mass of your solution. The mass of your solution can also be rewritten as the mass of your solute plus the mass of your solvent. Another one is actually mole fraction. So mole fraction, everything using number of moles. Again, it's number of moles of your solute divided by number of mole of your solution is equals to number of mole of your solute plus the number of mole of your solvent. So if you look at these questions, find the mole fraction of KBr if lab much KBr is mixed with lab much water. Here you need to know which one is solute, which one is your solvent. Apparently, KBr is actually your solute. Then we need to calculate the number of mole of your KBr. Again, it's the mass of the KBr divided by the molecular weight. Here, the mass of your KBr is 7.31 gram. The molecular weight, if you check out your periodic table, is actually 119. This gives you a number of mole equals to 0.06143. Then you need to know the number of mole of your solvent. Solvent is actually your water. Okay, so the mass over the molecular weight of your water. And that's equals to 50.0 divided by 18. So they will give you a number of 2.775. Then you can calculate the mole fractions of your KBr. Is going to equals to the number of mole your solute is 0.06143 divided by the sum of these two. So that's 0.06143 plus 2.775. So you are going to get a number of 0.0217. If you want to calculate the mole fractions of H2O, you need to put the number of mole of H2O in the numerator, and the bottom is actually, the same is actually 0.06143 plus 2.775. These are the 4 concentration quantification methods. So overall, you can see on the top is always number of mole or mass of your solute. At the bottom is always either the volume or the mass or the number of mole of the solution. Overall, I think for this page, these 4 different concentration terms, the concept is always solute over solution. The very last concentration that I intentionally actually put on different pages is the molality. Because for molality, it was defined as number of mole of your solute divided by the mass of your solvent. So this is very different from the other 4. This is actually the only one that your denominator is divided by a property of your solvent only. Not solution anymore, it's actually solvent only. And this is actually the mass of your solvent with a unit of kilogram. The molality is actually the only concentration terms that use solvent at the denominator. Here shows the example. Find the molality of 10.5 kBr is dissolving in 212 of water. Based on the definition that you know, you want to know the number of mole of your solute, which you know you need to calculate the mass divided by the molecular weight of your solute. Then you can know you need to put 10.5 divided by the molecular weight 109. And then you know the mass of your solvent, okay? It's very important, it's solvent, not your solution, okay? Is 212 gram, which equals to 0.212 kilogram. Then you can calculate your molality. It's going to equals to this guy divided by this guy. So I think I should make this one more clearly. 10.5 is gram, right? When you calculate your molecular weight, you actually have the unit of gram per mole. Because your molecular weight has a unit of gram per mole, this will cancel out. So this will give you a unit of mole. That's why I did not need to convert this one into kilogram, because when I convert it into number of moles, the molecular weight has the unit of gram per mole. So the calculation here will be actually just this divided by that, okay, then you got the answer of 0.416 m. So that's all the concentration terms that you need to know. Let's have a quick summary. So the first summary is actually we know the solutions is composed of your solute and your solvent. The mass of your solution is going to equals to the mass of your solute plus the mass of your solvent. And then we also know the number of moles can always be calculated by the mass divided by the molecular weight of your solute or solvent, where molecular weight is obtained from your periodic table. And this is typically given in the questions. Then let's go back to the 5 different concentration that you have learned so far. First one is molarity. So what it needs is the volume of your solution and the number of mole of your solute. So your M is simply equals to number of mole of your solute divided the volume of your solution. And then we know the normality is just equals to the molarity times the number of equivalents. Then we learn about the mass percent. We need to know the mass of your solution and the mass of your solute. When you calculate, it will be just the mass of your solute divided by the mass of your solution times 100%. Okay, the mass of solutions is often in combined with this. It may not actually give you the mass of solution directly, but it gives you the mass of your solute and mass of a solvent. Then what you need to do is actually to calculate the mass of solution from this equation. Then the next one is mole fractions. In order to get the mole fraction, you need to know the number of mole of your solution and then the number of mole of your solute. So you know the mole fractions is just equals to the number of mole of your solute divided by the number of mole of your solution. All these four, the denominator is actually your solution. The things that's different is actually your molality, right? Because the molality actually is going to require the number of mole of your solute and the mass of your solvent. So the molality is equals to number of mole of your solute divided by the mass of your solvent in kilogram. This table pretty much summarizes all the calculations. There's actually one more thing that you need to know, because one of the very big things that you are going to encounter in your homework is conversion between different concentration. So that conversion actually requires another equation. Density of your solution is equals to the mass of your solution divided by the volume of the solution. So if in the questions you see it provided density, it will give you actually 2 out of these 3 terms. Then you can calculate the third one, but most of the time it gives you the density, it gives you the mass of your solutions. So in this way, it actually tell you what's the volume of the solution. Okay, and that typically is going to ask you to convert to the molarity. So this is a quick sum up about the information you need to use to convert between different concentration. So here is actually the first example. Converting the molarity to molality. You have 3M HCl. The density of this solution is that much at that degrees. 3M, you know, that's actually the molality, right? So for all these conversion questions, okay, depending on where you get started, you need to actually make different assumptions. But the bottom line is that make the denominator equal to 1. They will make your life a lot easier. So for example, here you start from 3M HCl solution. So you know 3M means number of moles of your solute divided by the volume of your solution. Assume our denominator is equals to 1, which means actually I assume my V solution equals to 1 liter. Then I know the number of solute is going to equals to 3 moles. You want to convert the molarity to molality, right? So we know the molality is going to equals to the number of mole of your solute divided by the mass of your solvent. So this term, you already know the answer, right? So how do you get the mass of your solvent? You can see that it provides you the information of density, right? So let's say density of your solution is equal to 1.05. So the density of the solution is equals to the mass of your solution divided by the volume of your solution. From the question, you know your density is actually 1.050 gram per mil. You don't know the mass of your solution, but you do know the volume of your solution, right? Because we assume it's actually 1 liter. 1 liter is actually 1,000 mil. So that you know the mass of your solution is going to equals to 1,050 gram. But that's not what you are looking for, right? You're actually looking for the mass of your solvent. So you need to know the mass of your solution equals to the mass of your solute plus the mass of your solvent. So mass of your solute, since you have 3 moles of solute, then the mass of solute is actually number of mole of your solute times the molecular weight. And then that is going to equals to 109.38 gram. Okay, plus the mass of your solvent. Okay, and then your solution is actually 1050. So from these equations, you can actually calculate the mass of your solvent. Once you get that, you plug it back in here. You can get the molality of 3.189 m. That's, I don't think I have time to actually go through this and this. Okay, but I will upload my Hangout to tell you how to actually finish all the calculations. But the idea is actually all very simple. The rules you use is really summarized right here. So the first one is the mass is always conserved. The mass of your solution is equal to the mass of solute plus mass of your solvent. The number of mole is always calculated from the mass divided by the molecular weight of that species, where the molecular weight is actually obtained from your periodic table. For this 4 concentration terms is always number of solute divided by the property of your solution, either the volume, the mass, or the number of mole of your solutions. The molality is the only exception. Even though the numerator is still the number of solute, but the denominator is actually mass of your solvent, not solution anymore. In order to actually do the conversion between different concentration expression terms, this is actually another thing that you need to know. In other words, this table actually summarizes all the equations to memorize to do a proper concentration conversion between different expression terms.